Good morning, ladies and gentlemen. Do this now. What is the electric field? Question mark. And how can you tell an electric field exists at a point in space?
Pause the video. Write it down.
Do it now.
Okay.
Okay, so your answer should have been something like this. The electric field is the region around an electric charge where it can exert a force on other charges.
Yeah.
Okay, that's the answer number one. And number two should have gone something like this. The presence of an electric field is found by a test charge feeling a force.
Q prime.
Yeah.
That's right. Simple, yes?
Yeah, it's simple, okay?
So more review here.
For a point charge, the field radiates out into space like the spokes on a wheel. Right?
Yep.
Okay. Boop.
Yeah.
Like this. The direction of the electric field is defined as the direction of the force on a positive test charge. So if this is my originating charge and I bring in a positive test charge, okay, the spokes are going to go out. This is repulsion because this is positive and this is positive.
Yep.
Okay, and then over here,
If you turn it suddenly into
it's
negative,
a negative charge now. Okay, and now you get attraction. Okay, this is being attraction. Here it's repulsion. And so the direction of the electric field
and
is
the key word
defined-
here, it's defined.
defined as the direction of the force on a positive test charge. My pink test charge, zombie hand. Okay. All right, so attraction and repulsion. So these are pictures of attraction. And again, attraction is when we have those two, when the force, well, it looks like this, right?
Yeah, they
Okay.
reach across and trying to pull each other together.
Yep. And then over here we have repulsion, and they're
It's like, ew, get away from me, ew.
right.
You're disgusting.
And so that is what it looks like. Oops, wrong way. Okay. Moving right along here. If the electric field is this over this, the force over the test charge, and we know that the force is equal to this equation,
Yeah.
wouldn't the electric field be equal to this over that?
Yeah. Can you do you guys speak algebra? Can you simplify that thing?
Go ahead and try this out. Simplify it. We've done it once before.
See if you can do it on your own.
All over Q prime. Okay, so that's what I've got here. Okay, and essentially what we're gonna do is we're just gonna take this and put it up here. All right, because this is really like being over one.
Yep.
Right, so we're gonna say 1 over.
And when you divide fractions, you
prime.
take the one on the bottom, you flip it over and multiply it times the one on the top.
And now this is gone. Okay, and this are both on the top and the bottom, so we can cancel them.
So you end up with,
We're just left with this right here.
that's right.
Right? Okay, so that is what you get. We have two options here. The field is this.
That's the existential equation.
Yeah, the existential equation. And then down here, the measured field is this. So this is measured because it has that test charge in it.
And how do you choose which one to use?
Well, it depends what players you got.
That's right.
Right?
You got if you have a test charge and the force on it, you use this to find the electric field. If you don't have a test charge, you better have the originating charge and the distance from it.
So, an electric field, the electric field lines are drawn perpendicular to a surface. Do you see that? Like, so this is the surface right here, right? So each of these lines is going in perpendicular to it. Cool.
Yeah, what this is like mineral oil, like baby oil. It's got grass seeds, these tiny grass seeds on top of them. And you charge this one and you charge this one, the ring. And what can you tell me about the charge on these two things?
Well, what does this look like?
It looks like attraction to me.
Right? And
So
if this is positive, that means this is always positive, our test charge.
Could be.
That means that this is
negative.
negative.
Boom to boom.
Well, yeah, so they're opposites, right?
Yeah.
Okay, the shape of a charge's field is changed by the presence of another charge.
Yep, it doesn't look like spokes on a bicycle anymore.
No. Yeah, so this comes in, Okay, and the test charge changes.
Distorts the field.
Okay, the field. Now, why is this important? Well, we want our test charge to be as small as possible to avoid disturbing the field being measured. So if we're trying to measure this, it's ideal if this is as small as possible, as inconspicuous as possible, so that way we can get as accurate a measure as possible.
Yep.
Okay. All right, so here is we got a little question for you before we end up here. An originating charge of this many coulombs
Yeah.
has an electric field around it. Yes. What is the intensity of the field 1.2 miles away from the charge?
Meters.
That's
We
what I
could
said.
do miles.
Oh, sorry, did I say miles?
No, that's okay.
Meters.
So
away from
which
the charge.
equation are we going to use here, boys and girls? Take a look at the two that you've got written
So
down.
we have an originating charge,
Got Q originating, Q sub O.
and then we have the distance.
Is that a Q?
Oh shoot, what is?
That's okay. I haven't shown it to the kids yet.
Miss Moore is tripping, but I don't even know why I said P. Okay, so Q sub O is 6.0 times 10 to the negative 6 coulombs, and our distance is 1.2 meters. Okay, so we want to find the electric field. So that means we're going to use,
I think it's on the board right to your left.
it is right here. Okay, we're going to use K, Q original divided by the distance squared. Right. The other option would be the force over the test charge, but we don't have that information.
Don't got it.
So-
Can't do it.
Okay, 9 times 10 to the 9th Newton meter squared over Coulomb squared times, let's make it down there.
6.0 times 10 to the 6, negative 6.
6.0 times 10 to the negative 6 coulombs, all divided by 1.2 meters, and we square it. Okay, let's plug her in. All right, so I've got 9 times 10 to the 9th times 6 times 10 to the negative 6th, and I divide that by 1.2 squared.
Yep.
Okay, and I get 37,500, 37,500, 37500. 37500, and I'm talking about coulombs over meter squared.
Nope.
Coulombs? Oh no, no coulombs.
Actually, there are coulombs, but just do your cancellation. See,
Yeah, so coulomb here. Meter squared. It's a Newton coulomb.
newtons per
There we
coulomb.
go. Newton coulomb. There we go.
All right.
Bada boom. Good thing for units, right?
Yeah, absolutely.
Okay, so that is the electric field.
It's a simple thing. You just
Yeah.
need to recognize what you're doing, and if you got a calculator that can do scientific notation, then let the calculator do the work.
Yeah. Okay, so here is what we're doing for homework today. So we're gonna do the second page of Lost in Space, which is this one right here. So you're gonna start at number 5 and just finish it up.
Ooh, a drawing.
I know. Ooh. Okay. And then.
And if you
you're
want
gonna
to check
go-
with the other kids in the classroom, you should. It's not cheating.
No, it's not. Then I'm gonna read to understand page 482 to 43. So that's this one right here. So, and this is chapter 21. Okay, so 42 all the way to 43. Get a feel for what's going on here.
Not a lot of words, a lot of pictures.
Yeah, and then for homework, you guys are gonna do number 1 and 2 on page 484 as well. 1 and 2. 1, 2, 1, 2. Okay.
Okay.